Hello everyone, welcome to Learning Academy Foundation from Mr. Andrea. So, you want to talk to your computer. You type hello world and expect it to smile back. Adorable. But let's be honest, your computer doesn't care. It doesn't speak English or Italian or Japanese, it speaks binary. Zeros and ones. Romantic, isn't it? And yet, here we are, writing code like we are composing poetry, hoping the machine will just get it. Spoiler alert, it won't, unless we give it a translator. Let's unpack this linguistic mess together. We humans are sophisticated creatures. There are three types for computer languages. Low level, that can be machine language, binary, and assembly language, NASM. High level, classified in procedural language, for example, Fortran and Pascal. Functional language, for example, Haskell and F. Object-oriented, for example, programming language, for example, Python and C++. Scripting language, for example, JavaScript and Perl. And then specialized, for example, markup language, for example, HTML and XML. Query language, for example, SQL and Spark SQL. And domain-specific language, for example, MATLAB and R language. The specialized ones we will talk in another video later on. For now, we focus on low level and high level and their differences. Let's start from high level. We invented high level languages like Python, Java, and C++ because writing 011010000 is just bananas. These languages are readable, elegant, and make us feel smart. And we write source code, a love letter to the machine, full of loops, conditions, and variables. But guess what? The machine doesn't read love letters. It needs a translator because apparently print hello doesn't mean much to a processor. Now, if you are feeling brave or masochistic, you can speak the machine's native tone, the low-level languages. As we have seen before, can be classified in machine language and assembly language. Machine code, just zeros and ones, the linguistic equivalent of cave drawings. Assembly language, slightly better. You get words like move and add. It's like texting in abbreviations. And then you'll deal with opcodes and operands, the machine's version of grammar. Charming. So, do you want control, high accuracy, high precision, speed? Great. Just give up readability, portability, and your sanity. Let's compare these two linguistic beasts. High-level language is like reading a novel. It's easy for humans to read, write, and modify, while low-level languages is like decoding ancient runes. It's hard for humans to read, write, and modify. Then high-level language is about the speed, is slowish but poetic. Programs run slower as they make worse use of the CPU and are not very memory efficient, while low-level language is fast but emotionally unavailable. Direct control over CPU means memory use is more efficient and the programs run faster. About understanding high-level language, no understanding of how hardware components work is needed. The control is limited, like a tourist. Indeed, low-level language, there is a good understanding of how the different hardware components work is needed. And the control is total, like a dictator. Also about portability, high-level language works everywhere, while low-level language works nowhere else. Examples of high-level language are Python, Java, C++, and so on. While low-level language examples are machine code and assembly language. So do you want your code to be readable by humans or usable by machines? Because apparently you can't have both. Let's meet the middleman, the translators who make dysfunctional relationship work. Compilers, they take your entire code, judge it silently, and spit out machine code. They are efficient but unforgiving. While interpreters, they read your code line by line. So the intermediate code is closer to the source code. The preprocessing is shorter than the processing. Like a dramatic actor performing a monologue, they are slow but flexible to the interpreter. And then after compilers and interpreters, we have also assemblers. They run assembly language into machine code because someone has to. So from programmer to processor using the assembler and linker. Isn't it ironic that even machines need interpreters to understand our logic, and we still expect them to be intelligent? Now let's shift gears, because unlike machines, God doesn't need a compiler. In Romans 8:26 says, "In the same way, the Spirit helps us in our weakness. We do not know what we ought to pray for, but the Spirit himself intercedes for us through wordless groans." Even when our prayers are messy, incomplete, or full of syntax errors, he understands. You don't need to be perfect to inspire others. Let people get inspired by how you deal with your imperfection. We don't need perfect code to be heard. We need faith. So maybe the real question isn't can machine understand us, but can we trust the one who already does? Next up, motion. Because unlike your frozen screen, the universe actually moves. We'll explore velocity, acceleration, and why your coffee spills when you break too hard. If this journey through code and faith made you think, like, comment, share, and subscribe to Learning Academy Foundation, where we decode life one lesson at a time. See you in the next video. Bye.